In today's topic of Matlab, we are going to be looking at the input and output in Matlab. Now, for you to do well in this course, for you to be able to understand and be conversant with Matlab, I request that as you're studying this video, I should have your laptop in place. Whatever is being done here, whatever is being explained here, you should repeat it in your system. And we are moving to M file, that is script. So when you open your system right now, go to where you have script and click on it so that we can progress. Now we're going to be looking at user input in Matlab. When we talk about user input, we mean creating a situation whereby a user, some other person who is not you that is writing this program, can be able to impute values for the system to process the information that he or she has keyed in the values for. That is what we mean by user input. When we write a program based on user input, what it means that it is not just us who are the programmers that can use this program. Some other person who is not the person that wrote this program can equally use this program. So that is what we mean by user defined inputs. Now let's look at an example. Here we have Z. Z is a variable. So Z is assigned to input, name a value. So when you execute this particular command, what you're going to see is enter a value. This string that was written after the input function. So you can see it here, enter a value. So when you're asked to enter a value, once you place 5, Matlab, the system will assign this 5 to variable Z. Now let's look at another one. Here we have Z is assigned to input, enter value for Z in brackets. Now request the user to input a matrix such as this, and once you execute, this is what you are going to see. Now the second one is X. Input, enter your name in single quotes. Enter your name in single quotes and enter hello. So the system, if you execute this command, what you're going to see is enter your name in single quote. And your name, once you type hello, the system will assign holy to X. The system will assign holy to X. So this is how we do this input user-defined inputs. Now let's look at this one. X is assigned input. Enter your name. Enter your name, comma, quotation mark X means string. You're telling the system that this is a string. Now you need only enter the character, such as Raphael. So at this point, you cannot enter numbers because you have defined to the system, to Matlab, that what you are going to enter here is only string. Is only string. So numbers cannot work. So anytime you enter number, in this kind of situation, you are going to have an error message displayed. So let's look at this. This is a typical example. This is a typical example. This solution is developed in Matlab. Remember what I told you? Anytime you want to start any program in Matlab, the first thing you do is to type in your clear and CLC. Clear and CLC. Clear, erase all the variables that is stored in your RAM, while CLC clears all the variables on your screen. Now, percentage shows that this is a non-executable command. Here they say percentage request input from the user. Now we have here G is assigned to input what is the value of acceleration due to gravity. So the user will be expecting to impute the acceleration due to gravity. Start, input what starting time would you like. Finish, input what ending time would you like. Increase, input what time increment would you like calculated. Time equals to start time, increment, finish. Can you see it? Start time dot dot increment dot dot finish. So this is the time you have. So remember what we did the last time. If you convert this into number, this is the interval increment, and this is the start, this is the finish. So I believe you can remember this. Calculate the distance. Distance is equal to, is assigned to, now this is the formula. Plot the results. Log time comma distance. Remember title, S label, now when you run this program, this is how it's going to be. Immediately you run this program, what you're going to see is what is the value of acceleration due to gravity. You enter it 1.6. G will be assigned to it. The next thing, what starting time would you like? You enter it, it appears. So this is how you continue. You can see the graph. After the whole thing, the system will plot the graph. This is how to write a program in Matlab for user-defined inputs. So I would like you to pick up your system, repeat this program again, try to develop your own solutions, try to check problems that you have that you can develop solutions for, and try it over and over, and you become conversant with it. That's the only way that we can progress in this place. Now, the next thing is output option. We have looked at input. Input is how the user brings, apart from the programmer, another user brings values into a written program. Now, we are now looking at output. If you want your values to be outputted on the screen, how do you do that? How do you do that? The output of your work to the screen, how do you do that? So that's the stage we are now. Now, you have this value, variable x, and you want to display this variable x on the screen when you run your program. So you're going to use the function called display, DISP, display. If I execute this function, display bracket x, immediately I run this program, the values of x is going to display. Remember, this is different from when you assign x to when you assign 1, 2, 3, 4, 5 to x, and when you run the program, it will give you x is equal to, it will list the program. Now, with this, it will not do that. The only thing is that it will return, it will show on screen 1, 2, 3, 4, 5. So this is how display works. So anything you want to display on your screen, you use the function display brackets the variable. Display bracket the variable. The variable can be x, the variable can be y, the variable can be z. So depending on the type of variable you're using, that depends on what you are going to use. Let's take another example. Here we have display the values in the x matrix are display x. So if you run this program, the first thing you're going to see, the values in the x matrix are, then the system will display the variables because you have given two commands, display this and display that. So this is how we use display uh, function to put up variables on the screen. So I urge you to use your system. Try to repeat all these programs because if you're not repeating them, there is no way you're going to be conversant with them. So you are required to practice this, practice, practice, and practice, and it becomes part of you. Now let's look at this example once more. Now this one is a little bit different. Now we have display the value in the X array are number to string X. Number to string X. That number to string X is a command or a function that converts, is a function that converts number to strings. What it means that your numbers is not going to be seen as numbers again in the system. Rather, your numbers will be seen as string, as characters. So when you run this program, this is what you're going to see. The values in the X array are, it will list them together because this function, number to string, has converted these numbers to what? To string. Has converted this number to string. So if you write display number to string X, what do you think the system will return? The system will return 1, 2, 3, 4, 5 because the system has converted the numbers to string. So you can convert anything, you can convert any number to string no matter the distance. So, and here, this is another example, display hi there. I am your Matlab program. Who are you? Hi, name. When you run this program, now you're going to see input. Don't you just love computers? String. Don't you just run computers? String. Display answer. Display computers are very useful. You will use them a lot in college. So this is another program. When you run this program, this particular program written here becomes interactive. So I urge you to try and repeat this small program that is written here. Repeat it in your script, in your Matlab script, and try to run it. Try to run it, and you will see how it goes. So it is very important that you do this because it's only when you do this that you can be conversant with what we are trying to talk about. And finally, for the output option, we have what we call the fprintf. Fprintf, format string variable. Format string variable. Fprintf helps you to pick the variable value and insert it at any point where you want it to be. Let's take a look at this. Cow is assigned to 5. Now I want to print this on screen. I'll say fprintf. There are percentage F cows, percentage S cows. Anywhere the system sees this percentage F, it knows that you want it to insert the value of that variable cows, and which is 5. So there are percentage F cows in the pasture, comma, cows, comma, cows. Now, when you run this program, what you are going to see is there are 5 cows in the pasture. Somebody will ask, why 5 decimal places? It is 6 decimal places. That is the default for that value, F. Anytime you put percentage F, your values is going to be returned based on 6 decimal places. Based on 6 decimal places. If you use D, like in this second example, there are percentage D cows in the pasture. When you use D, the system is going to return an integer, 0 decimal place. 0 decimal place. That is what is going to return. Look at it there. There are 5 cows in the pasture without decimal place. So that's the difference between percentage D and percentage E. You have other percentage, you have percentage E, you have percentage F, you have percentage D, you have percentage G, you have percentage C, and you have percentage X. So all these percentage, they have their own functions. So let's take a look at this other example. Cows is equal to 6. Fprintf, there are percentage F cows in the pasture. Cows. When it returns, you know what is going to be. There are 5 cows in the pasture. There are 6 cows in the pasture. So it has repeated it because we have 2 variables that are cows. The first cow was 5 and the second one was 6. So if you want to display your value, you don't want it to be on a straight line. Look at what we did here. There are 5 cows in the pasture. There are 6 cows in the pasture. Now, if you want it to start under the first one, you don't want to write this sentence straight. You want, when you conclude this sentence, you start another one. You must put \n, \n after that comment. Look at it. Let's look at it here. Cows equals to 5. Fprintf. There are percentage cows in the pasture. \n, comma, cows. There are percentage F in the pasture, \n, comma, cows. Now, if you run this program, this is how you're going to see it. This is how it's going to look like. There are 5 cows in the pasture. It moves down. There are 6 cows in the pasture. If there is any other one that will have, it will arrange them in this form. It will arrange them in this form. That is that is what the \n does. So let's take this final example. The voltage is 3.5 millivolts. The voltage is 3.5 millivolts. Okay. Here we have voltage 3.5. Then want to print on the screen. We say the voltage is percentage 8.2. Let me explain something here. Percentage 8 means the number of places of integers we are going to have before we get our decimal points. And here we have specified that our decimal point is going to be 2 decimal places. If you leave it at just F, it's going to return default 6 decimal places. But if you put 2, it's going to return only 2 decimal places. If you put 3, it's going to return only 3 decimal places. And here, the 8 before the dot represent the number of integers the system can accommodate before the point. What it means that it can accommodate 8 integers, that is from 1 to 8. 8 numbers. 8 numbers, not just from 1 to 8. 8 numbers. It can contain 1, 2, 3, 4. It can contain 1, 4, 5, but 8 in number. That is what we mean by 8.2F millivolts. So when you run this program, this is what you're going to see on screen. The voltage is 3, can you see it? 0.50, 0.50, because of the 2 we have there. It gives 2 decimal places. Let's look at another example. This variable x is assigned to 1 to 5. That is 1 to 5. Now we want to print it. We now say f print f percentage 8.2 slash n x. So it will now bring this in as a column. Ordinarily, if you run this kind of command, you're going to see this as a row. But with this now, you have changed this thing to a column. Now you're going to have 1, 2, 3, 4, 5, 6. Remember why this thing is this way? You have 2 represents the 2 decimal places. 8 represents that you can be able to have 8 different numbers on your left, and 2 represent the number of decimal places you're going to have at your right. So this is how this is done. Okay, let's look at another one. Let's look at another one. Okay, here we have table. Table, the variable table has 1, 2, 3, 12, 24, and 36 as its value, as its matrix. Now we want to print it on the screen. I want it to be a kind of in a tabular form, in column. So look at it here. Remember, we'll have 2 rows here, 2 rows here. So the first statement here we represent row 1, and the second one we represent row 2. If you have another row, we continue like that. We continue to do it that way until all of them will be represented as a column. Now f print f, we have 4.0f for the first one. No decimal place. That is why you have 0f, no decimal place. And the second one is 7.2f, 2 decimal places. You have \n, comma, then table. Table is the name of the variable. Now, when you run this program, you're going to see 1 is to 12, 2 is to 24, 3 is to 36. So this is how we define our outputs in Matlab. Please, I urge you to pick up your system, try to repeat these things in your Matlab script and run the program. Do it 1, 2, 3 times and you becomes perfect. Thank you. See you in the next class.